We're going to continue our proportional and non-proportional functions discussion. We're going to focus today on equations and finish up with verbal descriptions. Proportional equations. Those are situations in which any equation can be described in this format where you have y is equal to kx. Now, k is any number, and it's kind of defining the relationship between the x and the y. Now, you're going to have that, and the thing that makes it proportional is that you're not adding or subtracting any constants. Okay, you're going to see some examples in just a moment. Remember, when we add or subtract that constant to this base equation, what ends up happening is we move it off of the origin. All right, we don't want to do that to make a proportional situation. So should not have addition or subtraction. Now, a non-proportional equation would be, well, the opposite. You have the same base, you have that y equals some constant or some coefficient times x, plus, and this is the disqualifier, the non part means that you're adding some kind of b. And that b does not equal 0. So we're going to look at a few examples. And we're going to determine how many of these 16 equations are non-proportional. Use this criteria. I want you to pause the video and just look at these first 4 and make a determination of which ones would be proportional. You can use a P for proportional and an N for non-proportional. First one, notice that we have our form y, some coefficient there, and our x. So that qualifies here, meets that criteria, but it does not meet the criteria of should not add or subtract. So since we're adding, this is not. And see, I'm not asking you to do any arithmetic. No addition, subtraction, multiplication, division, exponents, square roots, none of that stuff. This is 8th grade math. We're asking you to just look at the situation and determine if it's proportional or not. And just looking at this, just looking at these equations, if you see that something's being added or subtracted, that immediately disqualifies it. Look, I could say this is adding 0, right? But b cannot equal 0. So, hey, look, we're good. This is proportional. We have our y and our x in the relationship of the two. This one has a -2, so not proportional. All right, go ahead and look at the other 3 columns and quickly identify if they're proportional or not. Okay, y equals -3. That totally looks like it's proportional, but it is not. It is not. Can you think of why? Our first criteria says it has to be y equals kx. There's my y, but there is no x. That is why that one is not proportional. All right, not. This has a y and our x, that's proportional. Our y and our x, but it has that plus, so it's not. So again, you should, after seeing 8 of these, you should be able to go boom, 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 knock these guys out. Not is proportional. Not proportional. No, it's not. It's not because you're missing your y. All right, count those up and you'll have the answer to the question. Next, we're going to look at verbal descriptions. And the description should include a constant rate of change. That's my first criteria. And then it should be without any addition or subtraction. That's my second. So we have 2 criteria here for our proportional verbal descriptions. And what is it they say in English class when you're looking at a word, not quite sure what the word is, you have to look for context clues, right? Well, in this situation, because we're reading paragraphs of mathematics, what I'm asking you to do is look for context clues. Is there anything in that situation that's going to cause either you start off with something and then you increase or decrease, or is there anything in that situation which you'll be subtracting a value. So, and I'm talking about a constant value, not the constant rate of change. Rate of change, remember, has that variable attached to x. Of course, non-proportional is just the opposite. There's not a constant rate of change, possibly because of addition and subtraction. So I'm going to give you a few verbal statements. And I want you to determine which three of the following 6 statements describes a proportional situation. So one at a time, I want you to just I'll read it to you, and then I want you to just think in your head, commit, write it down on a sheet of paper somewhere. Doesn't have to be a fancy sheet of paper, just somewhere. And I want you to tell me if you think this is a proportional situation or a non-proportional. First one, Peter Piper's Pickles offers a buffet that costs $12.99 per person. What do you think? Proportional or non-proportional? All right, using our criteria, does it have a constant rate of change? It has a rate of change of $12 per person, and it's considered a constant rate of change because it is without addition or subtraction. There's no additional fee or delivery fee. You know, if they said, oh, it's $12.99 per person and we'll deliver it to you for an extra $5. No, there's no delivery fee or something like that. So this is definitely proportional. Looking at the next one, Chunky's Cheesy Cucumbers charges $2 per pickle plus $5 for cheese. So we have a rate of change, but it's not constant because it starts off with a plus $5 for cheese. So this is a non-proportional. All right, next, a 10-inch candle melts at a rate of 2 inches per hour. So if you're looking at the height, it has a rate of 2 inches per, I'm just going to use T for time. And notice that this candle, it's actually decreasing 2 inches per hour, and it started off with a 10. So it's this right here that disqualifies it and makes it non-proportional. All right, D. Lisa Simpson fills her pool at a rate of 5 gallons per minute. What do you think, proportional or non-proportional? We have a rate. Is it a constant rate of change? See, if this was an equation, we would say, I don't know, the gallons equals, 5 per minute? And there's nothing being added or subtracted, so this makes it proportional. Oh no, Bart pokes a hole in Lisa's pool, and it loses water at a rate of 30 gallons per minute. If I were to make this an equation, well, you tell me, what do you think? Is it proportional or not? So let's make this into an equation here. So we have the total number of gallons is equal to, see, it loses 30 gallons per minute. Are we adding or subtracting anything here? This is one of those context situations. Think about the situation. How can you be losing 30 gallons per minute unless you started off with some number of gallons, right? There has to be something already in the pool in order for you to lose it. So this is one of those context ones that you got to look out for. So this is actually not proportional, because the only way you can lose water is if you have some water to start with. And if we start with the value other than 0, 0, it's non-proportional. Finally, Homer, with his kids, he's got to pay $150 per hour for family counseling. What do you think, proportional or non-proportional? There's nothing in this scenario that shows that we're have any addition or subtraction. So what we're going to end up doing is calling this proportional.